Okay, now I think it would make a lot more sense when you apply this to physics and you would really see it. So when we say differentiation, we're basically talking about the gradient. We're basically talking about the gradient. And when we integrate, we're basically talking about the area. So we're going to be seeing three graphs. This is going to be the displacement time graph, velocity time graph, acceleration time graph. So let's say our displacement time graph looks like this. Our velocity time graph will be this, and our acceleration time graph will be horizontal line. So if I differentiate the function or the equation of the displacement time graph, I'm going to end up with this graph right over here. And if I differentiate this, I'm going to end up with the acceleration time graph. Now, if I integrate the function of the acceleration time graph, I'm going to get the velocity time graph. If I take the velocity time graph function and integrate it, I'm going to end up with the displacement time graph. So that's what this diagram is showing us. If I differentiate displacement with respect to time, I'm going to get velocity. If I differentiate velocity with respect to time, I'm going to get acceleration. Same thing if we do in reverse, we're going to go back to velocity. Again, we're going to come back to displacement. Okay, so that's what you have to understand. This is a bit of recalling of your unit 1 as well. And now we're going to be seeing how to apply this in some questions from unit 5, oscillations. Now, there are many good ways to do this question, and I will teach you that when we go to this chapter. So there are a number of ways. There are 2-3 ways to do this. But if you're able to memorize the integration and differentiation rules, you can do these questions in about 10 seconds, 20 seconds max. Okay, I'm going to be a bit slow because this is going to be the first time you're going to be doing something like this. So all you have to look at is the graphs and stuff, and that's all. You don't have to really understand even the chapter that much. Okay, so first they've given us the force time graph. Now, the force time graph is just the acceleration time graph in disguise because force is directly proportional to acceleration. So this is actually just an acceleration time graph. That's the first thing you have to notice here. And then they tell us which graph shows the displacement of the object that varies with time t. So we have this acceleration time graph, right? And we have got this function right over here. This is going to be sine x. And they're telling us they want the displacement time graph. Okay? So basically, going from acceleration to velocity, velocity to displacement, that's integrating. We just saw that, right? So integrate and integrate. Okay? Now, look at this very carefully. Now I'm going to connect it to what we just studied, right? So sine x, minus sine x, cos x, and minus cos x. So integrating was which direction? It was anti-clockwise. So sine x, you integrate, you get minus cos x. So velocity time graph will be a minus cos x graph. So it will be something like this. And then your minus cos x is going to give you minus sine x. You integrate again. So that's going to be something like this. Okay, basically the sine x graph but flipped. Okay, so we can easily do this now. So part A is asking us the displacement time graph. So that's going to be graph number D. Notice graph number D, it matches this graph. So it's going to be D. And velocity time graph is going to be B. It matches B. So that's going to be that. So I hope that's clear. Now let's move on to the next part. So we've got the next question here. We've got the velocity time graph now. So velocity time graph. And this is a minus sine x graph. Okay. This is going to be a minus sine x graph. Now, we're going to go from velocity time graph to displacement time graph. So that's going to be needing some integration. Okay. So it's a very simple thing. You write your diagram again, sine x minus sine x cos x minus cos x. So we are right over here. Okay, and we need to integrate, so we need to move to the clockwise direction, or anti-clockwise, my bad, anti-clockwise direction, and that's going to give us cos x. So cos x graph looks something like this, and that's going to be A. That's your answer. The next, we're going to be looking at this question. So we've got the displacement time graph now. So it's going to be this, and this is actually going to be minus cos x graph. So we're going to need the velocity time graph and then the acceleration time graph. Now we're going to have to differentiate. Okay, so I'm going to write sin x minus sin x cos x minus cos x. So now we're going to be going clockwise. So minus cos x, it's going to go like this. So sin x, so you should get something like this. And from sin x, we're going to go cos x. So something like this. Okay, so we're going to go from minus cos x to sin x to cos x. So this is going to be the velocity time graph. So that's going to be sin x, that's going to be d. And then the next one is going to be cos x graph. So 10 is going to ask us about acceleration time graph. So that's going to be cos x, so that's going to be A right over there. Okay, so this is how you do it. If you don't find this very comfortable or easy to do, then I have some other ways as well. We will discuss the other techniques to do this question when we do unit 5 or when we go to this chapter.